Lesson 120, volume of pyramids, cones, and spheres, surface area of pyramids and cones. So we're finding volume and surface area of three-dimensional figures. There are formulas for these figures, but they aren't worth the trouble in most cases. We can kind of create some shortcuts. If you look at page 378 towards the center to 2/3 of the way down the page, it gives you a quick way to find volume for right solids that will then give you the volume of these shapes that I've got shown for you here. Instead of trying to find, remember, volume is what fills up inside of this. How much air fills this inside of this triangular pyramid? Instead of finding it with a formula, what we're actually going to do is find the volume if it were a right solid, so that the top was the same as the base, like this, and then came down. That's what we're used to doing, where the top is squared off. And the volume of it, if it has a peak like that and it's a pyramid, is just going to be 1/3 what we're used to. And what's volume of a right solid? It's area of base, which we can find. It's shaped like a triangle. We'd find the area of that base times height. So just do 1/3 of this, of the full right solid, and it'll give you the original shape we had. Back it up. Same thing is going to be true with the sphere. Instead of trying to find volume of a sphere, we just find the volume of a cylinder with like so. If we find the volume of this and we use the area of this area for my base and then multiply by the height, just take 2/3 of that volume of the right solid, the cylinder. Okay, and these formulas are listed on 378. And the same thing with this cone. You would find 1/3 the area of this shape that we have used before. Now the bad news is we haven't always been successful with some of those shapes either, so you're going to have to grow comfortable with your volume formulas. Same thing with this. We'll find the area of a right solid and then just take a fraction of that. So if I need to find the area of this, what's called a triangular pyramid, why is it called triangular? We name solids by the shape of their base. That's the base. If I know that this is 6 and this side is 3, and we take a look at what that means, if this is the right angle here, take a look at that base, 3 and 6, and we're finding 1/3 of the area of the base times the height. Well, area of the base, 3 times 6 divided by 2 should be 9. Maybe I should write that over here. Let's go with this. Area of the base was 9. Multiply that by the height, which the directions have told us is 4. So this height is 4. 4 times 6 is 24. What do I need last step? I'm only finding, 4 times 9. 4 times 9 was our area, is 36. And what did we say? Find 1/3 of that. So 36 divided by 3 is 12, is our volume of this shape. With the sphere, we will find the volume of the sphere with a radius of 10 by figuring it like it's a cylinder. And how do you find volume of a cylinder? Area of the base times the height. What's the area of a circle with a radius of 10? Formula for area of a circle. Pi 10 squared. That comes out to 314, I would think. Multiply that by 20, because 20 is the height according to the directions. That is 20. Final answer, if you multiply this by 20, is 6,280. Almost done. Surface area, right? Surface area. For a shape like this one, you'll need to find the lateral surface area all the way around and the area of the base. Add those together for a total surface area. Lateral surface area of a cone will actually use the slant height, not so much the actual height. And lateral surface area of a right circular cone, like you see here, is pi r L. So 3.14 times the radius, in which case, let's say the radius is 5, and the S here, the slant height, is 6. Pi times 5 times 6 is 94.2. I'm kind of doing the problem at the bottom of 380. Why am I not done? Because that was the LSA. I still need the area of the base. Total surface area takes this plus base. Area of a circle, pi radius squared, 3.14 times 25 comes out to 78.5. Last step, what is it? 78.5 plus 94.2, the LSA. So take the area, 78.5, plus the LSA, which is 94.2. That's 172.7. 172.7. Yikes. 172.7 is the total surface area of this right circular cone. This last one, to find surface area, we're going to find area of the base, which is just a 4 by 4 square. 4 times 4 is 16 square inches, we'll say. Now, notice how each face is just its own triangle, and the triangle's real height is 3 feet. So 3 times what's the base of the triangle? 4 divided by 2. Area of a triangle, right? 3 times 4 divided by 2 is 6. So the area of one face is 6. How many faces? 4. 1, 2, 3, 4. All the way around the pyramid. So 6 plus 6 plus 6 plus 6 plus that 16 we had comes out to 40, I hope. We'll say inches. The book used centimeters. No, meters. That one is example 120.4. Remember, with surface area, we are finding the square inches or footage, whatever we're measuring, of each surface. You know, on the base, maybe we can color black. No, brown. Okay, each surface. Okay, like we did with this one. Square footage around, square footage of the base. This was space filling up. Filling it up. Air inside, if you will. Not the amount of carpet it would take to surface this pyramid. So formulas are there for you on pages 378 to 380. Takes you back through the same problems. You can always watch this video again. I hope it's helpful. Please pick a surface area and a volume problem from the practice choices on 381. Show those to me. Thank you for viewing. Good luck.